So welcome. My name's Christopher. I work with the Education and Application Support team, and I'm joined by one of my colleagues.
Hey there, Christopher. My name is Dave Thomas, and I also work with the Education Application Support team. I guess the official title is Advanced System Support.
What we're talking about today is about directivity is really the big story, but it's improved intelligibility. And D&B has been passionate about this. And we, from the very beginning, directivity of loudspeakers was exceptionally important for us. So that's what we want to really talk about. And when we talk about directivity, why are we so concerned about directivity? And it really has to do with this idea of intelligibility. And if we talk about intelligibility, we kind of want to define it like this: of good quality, understandable, and faithful sound to every seat in the audience area. And this way we can ensure that everyone is getting the same sound, the same show. And if this is our goal, what are the things that we have to consider when we're talking about being able to create an intelligible show, to be able to say that this show, this message, this convention has an intelligible audio quality? The first thing we really need to take into consideration is this idea between the direct and diffuse sound. So we all know that sound does not go from our mouths directly to someone's ears, or from a loudspeaker directly to someone's ears. What's ultimately happening is sound is bouncing off of walls, ceilings, floors, anything that's in the room. So there's this idea of direct sound that's going directly to the audience, and then there's also the sound that is bouncing off surfaces. Now, if we were to take just a very generalized look at how sound bounces around the room, we did a simulation in Ulysses where we have the loudspeaker on the very right side of this rectangular room. And you have this blue line which represents ear height, and then you have the black line representing direct sound. And then we put sound into the room with a single reflection, meaning it hits a wall, comes from the loudspeaker, hits a wall, and then arrives at our measurement point. And then we do a second reflection, and a third, and a fourth. And you can see each time we add a reflection, we're increasing the diffuse field within this room. In essence, we're reducing the intelligibility. And given the speed of sound, this happens very, very quickly. So this is really the key portion. Like, we can have the best sounding sound system with the cleanest signal path. The biggest problem is always between the loudspeaker and the listener. So how can we improve our direct to diffuse ratio? What you see on the screen is kind of this idea of a graph of how the direct to diffuse ratio works. So we have our direct sound here, and we have our level of the diffuse field. So there are a couple different points to take a look at here. The first is critical distance. Critical distance, as I'm sure everyone's aware of, is the point which the direct sound and the diffuse field is exactly at the same level. And then once you get below the diffuse field, your SPL meters stop working. This is where your SPL meter stops working. It will not get any quieter. It'll just simply be measuring the diffuse field. However, human hearing, we can actually hear up to 10 dB below the diffuse field. So we can still get intelligibility well below what we can actually measure, which is really a testament to the ear-brain system being able to pull out useful information. Now, how can we actually improve this ratio? A common way that people think is the best way to do is to just turn up the direct sound. And as we can see, that really doesn't work. We're simply, the direct sound is going to turn up in direct relation to the diffuse field. So turning it up is not going to be the solution. Another solution is what we really are trying to do is reduce the diffuse field, create less reflections. And to do this, we need to have a loudspeaker that is well behaved. Now, what do we actually mean by a well-behaved loudspeaker? More often than not, we're talking about a loudspeaker that has pattern control. But it's more than just pattern control. But let's take a look at a couple of different ways that we visualize pattern control. More often than not, everyone's going to be familiar with a polar plot, where we're seeing a view around a loudspeaker in both the horizontal, and in this case, horizontal and vertical, where we can look at individual frequencies. And oftentimes, they're put down in terms of octave bands. However, if, say, I wanted to know what kind of pattern control I had at 3K, excuse me, I would kind of have to guess or hope that there's a polar plot somewhere. Another way to look at the pattern control of a loudspeaker is with an isobar plot. Now, isobar plot is a measure of equal pressure, and it gives us an idea of the pattern control of a loudspeaker. So we have the loudspeaker on the right-hand side of the screen, and then this red line represents its on-axis behavior. Now, anything within this yellow area is going to be within 6 dB of the on-axis level. Anything in this lighter gray area is going to be 6 dB down, and in the darker area, it's starting to get to be 12 dB down. Ideally, we would like these lines to be as parallel as possible as you go from the 6 to 12 dB down. That way we know as we go off axis, instead of just that we can ensure that it is sounding consistent. If these lines are parallel, it'll sound like the loudspeaker's just getting quieter, as opposed to having a frequency response change. So that's going to be one of our goals. The other one, which is harder to do, is we would like them to be completely flat from 20 kilohertz all the way down to 20 hertz. Now, that's not entirely practical, but that's kind of a goal. We want pattern control down to the lowest possible frequency we can possibly get. So how do we actually get directivity? One of the most basic ways that we can get directivity has to do with the size of a loudspeaker driver. And it is directly proportional to the size of the driver that gives us pattern control. So if I take a 5-inch driver, it has a wavelength, the size of the driver equates to about 2.7K or 2,700 hertz. And if I put in 2 lines representing 45 degrees off axis in each direction, or 90 degrees of coverage, this is the point where we will say that the loudspeaker will continue to widen out. It will no longer have the possibility of becoming directional. It's only going to go omnidirectional. And as we can see with this isobar plot, with a 5-inch driver, we get this idea of proportional directivity, meaning the loudspeaker gets less directive as we go lower in frequency, depending on, and this is going to be dependent on the size of the driver. So what happens if we go to a larger driver? Let's say a 15-inch driver. Now, the wavelength across a 15-inch driver is about 900 hertz. We put in that same 90-degree coverage area, and we can see that that isobar plot lines up directly at 90 degrees at that 900 hertz point. So one of the ways that we can get directivity is simply increasing the size of the drivers. So very small drivers only control up to higher frequencies, make them larger and larger, and they get to lower and lower frequencies of pattern control. However, we know how this works out. We can't make these drivers infinitely large. Bad things tend to happen. So what do we need to do in order to get pattern control from a reasonably sized cabinet? There are a number of different techniques that we can employ, that D&B does employ, for trying to get pattern control. And I kind of want to walk you through some of the milestones that D&B has that gets us through this idea of directivity and how we're striving to get more and more pattern control to improve intelligibility as we move further through time. So first loudspeaker I want to talk about is the C7. This was released in 1997. I'm sure there's a bunch of folks in the audience who are familiar with the cabinet really, really like this cabinet. 75 degrees in the horizontal, 40 degrees in the vertical. Excellent sounding cabinet, great pattern control. The catch was, it was 115 pounds or 52 kilograms. Easy enough for a pair of people to put onto a stack, like on a stack of a sub, on a C7 sub or a B2 sub. Not exactly something that you can deploy on your own or on a loudspeaker stand. So there was the desire from the market to have something smaller, something that's easier to deploy, but had the same pattern control and as close to the same frequency response as the C7. So took a couple years, but the engineers found that they could actually do this. And then they released in 2003 the Q7. That again was 75 degrees in the horizontal, 40 degrees in the vertical. Very similar frequency response, actually went lower in frequency response. Same SPI output, but only weighing 49 pounds. So the question is, how were they able to get this small cabinet to have almost exactly the same features as a C7? And really, we just took advantage of physics. And it had to do with the addition and subtraction of sound waves. So when we talk about two sine waves that are same amplitude, same frequency, arriving at the same time, we're going to get a 6 dB boost at our measurement point. However, if they're 180 degrees out of phase, we're going to get a point of complete cancellation. Now, why are we going over these basics? The reason is this is what we use to take advantage of it. And it's this idea of a dipole. The Q7 had two 10-inch low frequency drivers, and they were spaced a distance apart that we could allow to take advantage of this addition and subtraction of sound waves. So as an example of how a dipole behaves, we have two drivers spaced 1/2 wavelength apart, and the sound is arriving at our listener. And here we're getting a 6 dB boost. As we start going around to the side of the loudspeaker, we get to a point where we are 180 degrees out of phase from one loudspeaker to the other. So we get that cancellation in the direction of the dipole. So if we're talking about the Q7 and say it's portrait orientation, we have really excellent pattern control in the vertical so that you can hang it above someone who's talking into a microphone and you minimize feedback into that microphone. You also minimize energy into the ceiling and it reduces the diffuse field. You can also rotate that cabinet 90 degrees so you can minimize energy bouncing off walls. So first step into directivity. A couple years pass, people are like, we want a bigger cabinet. Q7 was doing, Q series in general was doing bigger and bigger projects that really wasn't intended to do. So there was demand for a larger loudspeaker. And that was the creation of the J series. which at the time was the standout line array system, and to a degree still is an excellent, excellent system. But we'll be talking about something that I don't want to say it replaces it, but it definitely, there's some definite improvements. So with the J, that's a little bit bigger than the Q, but this had the additional benefit, it was a little bit louder, but we have, in addition to your high frequency element, we've got a mid frequency element that actually has two openings. So they behave as a dipole. So when the HF loses pattern control, it hands off the signal to the mid frequencies. And that mid frequency driver, because it's a dipole, you're getting that dipole behavior and it's maintaining pattern control. And then once that the frequencies get larger, the wavelengths get large enough, frequencies go low enough, you have to pass off that signal to the low frequency drivers, which then maintain that pattern down to a very low frequency. In the case of the J, down to 250 hertz, where we get to about 100 degrees off axis, where it's like that starts becoming a little bit too wide. But in general, very, very well behaved loudspeaker. So we've got the J series, and it controls down to 250 hertz. Cool. And then in 2012, we released the V series. Now the V series, significantly smaller cabinet than the J, only 75 pounds. However, it controlled down to that same 250 hertz. And that is going to be a combination of that same double dipole that you have with the mid frequency and the low frequency, as well as some additional technologies that we learned and kind of incorporated into the V series, as well as having a very similar SPL output. Not as low frequency response, but it's a small cabinet. Don't want to ask too much from it. So while we were working on the top cabinets, our mid-frequency, high-frequency cabinets, we were also working on pattern control to the lower frequencies. And that's where we start talking about what some people might refer to as the black magic of sound, which is low-frequency directivity. If we take a look at the pattern for a typical omnidirectional source, you're going to get energy going to the front, and you're also going to get that same energy from that front firing driver towards the back. Generally, you can be reduced by like 3 dB, and that's really a function of the frequency that's coming out, as well as the cabinet that is surrounding this driver. But in general, omnidirectional sound is radiating spherically. One way to get pattern control from omnidirectional subs is to do something like a cardioid subwoofer array. This is a first attempt at low frequency directivity, and this was 2004. And in this case, we took 3 cabinets, 2 amplifier channels, and we turned one of those drivers around. And then we put an all-pass filter on that so that we could control on a per frequency basis delay times. And that allowed us to delay the energy coming out of that rear firing driver so that it arrived, that the sound arriving from the front as it wrapped around to the back arrived at the right time and in the right phase relationship to create a cardioid polar pattern. Yeah, and I'm sure people have done this quite a bit. And it's still a very popular, you can still do it. I mean, if you have Q subs, obviously you can still do this. B2s, B22s, B6 sub, all are capable of creating this cardioid behavior with using omnidirectional subwoofers. We took this same idea and incorporated it into a single cabinet with the J sub and the J infra. And this was starting in 2006 with the J sub, and then in 2008 with the J infra. J sub was a 3 times 18-inch low frequency driver, while the J infra was a 3 times 21-inch low frequency driver. Powered by 2 amplifier channels, they allowed you to have cardioid behavior with just a single cable going to each subwoofer, but it also allowed you to have hypercardioid behavior. So you could change the cancellation to the rear based on time, adding different filter sets to those subwoofers. Really, really flexible. Pattern control to really low frequencies, great rejection to the rear. And this was great. Everyone was thrilled by it. However, our engineers in Germany wanted a challenge. They wanted cardioid behavior, but they only wanted to use a single channel of amplification, which is, by all rights, difficult. The only way we've done it thus far is with two channels of amplification, either with a stack or with a J infra, J sub within a single cabinet. And in 2009, we came out with the B4, which was a passive cardioid subwoofer using a technology called PSP, or plywood signal processing. The same signal that was going to your forward firing driver went to your rear firing driver. What you see on screen here is the patent drawing for the cardioid behavior. And you see you have three isolated chambers, one for your forward firing driver and one for your rear firing. The chamber at the rear top is for the compression, and the chamber at the bottom is for the rarefaction of that driver. And based on the construction of the cabinet alone, we can get cardioid behavior within a single cabinet with a single amplifier channel. And the way this works, same idea of energy going from front to back. So energy is going to come out the front, and it's going to wrap around the back. We wait for that energy based on the construction of the cabinet to create the cancellation as it exits out the ports to the rear. The added benefit of this is that energy coming from the back to create the cancellation actually goes out front too. So we actually get a little bit of addition out of the cancellation. So we get generally, it's about 12 dB or more rejection to the rear of the cabinet. And we probably get 1 dB of addition to the front of it. And this is, again, using a single amplifier channel. And there are a whole lot of subwoofers available that support this PSP. Of course, the B4 was the first one, closely followed up by the 27S, which is an install flyable or ground stackable subwoofer. Then the V sub, Y sub, VG sub. And then you also have their install variants, the YI and the VI. Acoustically exactly the same, but no handles, no wheels, intended for applications where fixed installation, they're not going anywhere. So this gives you an idea of this, how much D&B has been obsessed with pattern control. I mean, even going back into late 80s, getting pattern control onto 800 hertz, all the way up through current day, where we now have we can actually achieve pattern control down to 45 hertz. And that's where I'm going to hand it off to Mr. Dave Thomas.
So as Chris was talking about, there's all this talk of Germans being passionate about directivity, right? And so what's that last bit that we've been talking about? He was talking about, the J series, our flagship line array product of having pattern control down to 250 hertz, which was amazing for that. But there's that last bit, that we were trying to figure out as D&B, how can we do better? And so as that timeline showed, that the SL series is kind of that part that we're looking to talk about now. So it's a new family, it's a new series. You may be familiar with it, but at the same point, we have some new toys to show. But that last bit that we've been talking about, right? So here's that 250, 200, where it just becomes omnidirectional. And this is that problematic area, with noise emissions and reflections into rooms, right? So if we're talking about far field emissions, who's the troublemaker? It's this omnidirectional side there. So if we're going to talk about the SL series, and as that line showed, having directivity down to the lowest octave, now that we're familiar with isobars, how does that look, right? And here's where it is. So this is the KSL 8, showing that directivity of 80 degrees down to the lowest octave. It actually widens out a little bit on purpose for two reasons. They were looking to make sure that we had a lot of headroom in the LF, and so they were able to widen it out just a little bit to give us some of that back, as well as being able to pair with ground subs a little bit better. But take note that this is just an isobar of one cabinet. So as we add more to the length of the array, this is only going to clean up that much better. So how did they do it? So let's cut off the top of the SL series here and take a look inside. So we can identify the rear and the front here, and we can see a front-loaded driver as well as a side-loaded driver here. So taking some of these principles, part of the evolution of how can we take that thought and improve on it to make it something that we could use as technology was updated along the line. So remember how there was having one driver and then a second driver and kind of using, well, I guess you can almost think of it as an end fire, right? If we do a time and a delay and spacing, that we're able to go and do something that gives us this, the addition to the front, right? So time and spacing gives us this. Or to the rear, what happens there is the attenuation, right? So that addition that we're getting to the front would be if we took that side-loaded driver and put it on the front baffle. We're getting all of the available energy that's coming from there, complete addition, as well as we see here, the attenuation to the rear. But this is talking about a higher octave, as this radiates off the front of the cones, right? But we're talking about even extending down to the lower octave. But if we take a look, we can see that there's these bass reflex ports in each one of the chambers there. So as we're talking about lower sound waves, we're talking about longer wavelengths, right? So how do we control that? And what they were able to figure out is if we place these bass reflex ports as far away as possible from each other, and even at the length of them too is going to help us with timing, we're able to then get the attenuation to the lower octave as well. So quite crafty in the design and just waited for technology to catch up a bit. But while we have the box cut open, let's dive in a little bit more. So there's two parts of the SL series. There's the GSL and the KSL. But for the most part, they look the same on the inside, but let's talk about the differences. So for the GSL, there's actually three 3.4-inch voice coils for the HF, and that's really because the GSL is made for the largest venues in the world. Talking about the name, if we can go German for a bit, so gross means large or big, right? Special loudspeaker, and K or klein, meaning small special loudspeaker, able to handle those two applications. But we'll see that the KSL is anything but small by the specs here in a bit. So for the GSL being the largest for the largest venues in the world, definitely needs some more horsepower for the HF, as we're going to be throwing the longest distances there. But for the KSL, it's the two 3-inch voice coils. And then for the mid, we have in the GSL a single 10-inch, and that's in a sealed volume in itself there. We can see that's mounted directly behind the HF driver. Chris was talking about dipole technology to be able to control the pattern of what's coming out of that. And we can see right around the waveguide of the HF are two exits. So we're getting that nice pristine pattern control of the operational range of that mid driver in its sealed volume there. So 10-inch for the GSL, 8-inch for the KSL. And then we can see the forward firing drivers there with their bass reflex ports. Those are highlighted a little bit better too. So we have the forward firing 14s on the GSL and then the 10s for the KSL. And then not to be left out is our side firing drivers, where we can also see the bass reflex ports there. So the double 10 and then the double 8. So what's interesting about this is, like I said, we get complete addition to the front. So we can almost consider the GSL with the addition of cone mass to be a double 17. Really, if you take the addition of the 14 and the 10, and then for the KSL, we can consider this to be with a cone mass addition of a double 12. So even though the boxes are smaller, they definitely have the impression of something much bigger, in the LF in particular. So how do we power that? So like the J series, this was a two-way active amplification. And what that means is that it needs 2 amp channels to make this happen. So channel 1, as you might guess, is using all of the available power of the 4-channel amplifier, in GSL in particular, the D80, to give that its power, the amount of voltage that it needs to really give us some amazing output there. And then everything else, the high, the mid, the side firing drivers, are on a through-way passive crossover on channel 2. And if you're not familiar with D&B and you say, wow, passive crossover, really? They have figured this out from the 80s. Back to some of the first loudspeakers, it's been passive crossovers. In fact, there's probably more D&B products that are using passive crossovers than active. But this also helps us do a couple of things. If we draw a line from our side firing drivers right across to the other one there, we'll see that everything is already on channel 2 timeline. And then by having channel 1 separate, we're able to then go ahead and do any alignment in there. So really trying to, as much as possible, fix everything in the box before we have to do anything more with the DSP. So more PSP, as Chris said, plywood signal processing versus a DSP. But why so crazy about full broadband directivity, right? I mean, let's just break it down. So this is now controlled. Our dispersion pattern, as you saw in the ISO bar there, we're able to actually get the sound where we want it without having to worry about the omnidirectional aspects of it. But the wider usable coverage thing is something that's just so strange for us to take a listen to. I'd love nothing more than to say, after our presentation here, we're going to go take a listen, where as you walk off access, it just gets quieter. Where other products you may be used to as you walk off access, the mids and the highs are taken over by this omnidirectional low, right? So now, as we walk off access and it just gets quieter, we can almost say that there's wider pattern. There's a wider usable coverage. So we can have more seats that just get less SPL to that side there of perfectly good coverage. And less stimulation of the reverberant field. I mean, think of it as we're placing speakers in a venue that typically there's some sort of, as I like to call it, parabolic reflector of some sort behind the loudspeakers, right? So the omni side of the loudspeaker, the omnidirectional aspects, all that low, mid, and low stuff, takes time to go hit a reflector and then back into your audience. So if we're not stimulating that reverberant field and yet having everything come out to the front as we were hoping, it's going to be much, much better quality. Arrival times are going to be much more precise, sounding much tighter in some of the worst rooms, right? But less spill from the house system into open mics. I mean, think of how high we sometimes have to hit our high pass filters for, say, an orchestra, right? The arco bass is playing away, but in order to get anything into the PA, we've had to actually turn up the high pass filter maybe more than we'd want. Or think of corporate shows, talking head stuff with lapel mics or a lectern mic. Once again, wanting that CEO to come out and the first impression to sound nice and full, and having that sort of rejection to the rear, that we can actually have our high pass filter lower than maybe what we're used to or accustomed to. And take all that and combine that into our far field emission software called NoiseCalc for superior noise prediction and mitigation. So if we're looking to plan a festival or an outdoor venue and there's a neighborhood around this, think of the possibilities now that we don't have that road range anymore affecting the far field emissions that we've been worried about. So to capitalize on something that's been out for a while, though, is array processing. So we're able to, if you're not familiar with array processing, what this helps us with is the tonality over our listening plane, so that the front seat sounds as good as the back seat. And this is something that is available for certain with the SL series. So we're able to deal with that, not only tonality, but level over distance, but it also improves our vertical directivity. So we talked about the SL series having that horizontal directivity now, but now with array processing adding on to it, we're also controlling our vertical side of it. So really having the sound exactly where we want it has been that last bit of where D&B has been going for their obsessiveness and pattern control. So does size matter? Sure. So depending on the size of your screen, this is not maybe to scale. But so the J series, as Chris was talking about, and this was our flagship product for several years and is still used in some of the largest applications for mobile and venue deployment. But let's see where the GSL comes into the things here. So it is a larger box for certain, because once again, we talked about needing more headroom and wanting to have a box that's able to do the largest venues in the world with broadband directivity. So while it's wider, look at how much taller it is. It's not too tall considering all the advances that are in this box and the extended LF output that we get from something like that. So where does the KSL fit in this? So having a lot of the similar output potential that we were able to get out of the J, but now having broadband pattern control, we have a smaller and lighter box now as well. So the SL series is definitely something that we're seeing is being welcomed into the industry quite well. So let's look at the specs here. So starting with the GSL, there's a GSL 8 and a GSL 12. If you're not familiar with the naming structure here, the 8 would be the horizontal pattern, so that's 80 degrees of horizontal coverage, and the 12 is 120. And we can see that as this box, I mean, it is a very powerful box, not only with SPL, but also being able to go down to 45 hertz. But still relatively lightweight, considering maybe some of the other products that are out in the market, being able to say 176 pounds or 80 kilograms. And this is powered as we talked about earlier. So 2 channels are needed to power this. There is no linking of this just because the drivers that are in there needing so much voltage. So it's literally 2 channels or a pair of channels for each loudspeaker there. So next product is then the KSL. And what's interesting about this is we're able to also talk about now the KSLi. As you may have heard Chris talk about, that the I is meaning install variant. So we can kind of gain from this picture here that we've cut off the handles and we're making this look much cleaner, and we're able to shave off a little weight because of some of the savings that we've done with that. So still keeping the same acoustic specs though, where the KSL goes down to 54 hertz, still having an impressive 145 for the KSL 8 or KSLi 8. And then we have the NL4 or the optional Phoenix socket as well. That would be maybe something that's required for an installation. And we have different variants that we're able to be more specific with or more helpful with depending on your installation. So the special color, the weather resistant, the special stadium version, as well as sea weather resistant. And I'll get into that in a little more. But the KSLi in particular is where we could take advantage of these additional variants. So that's a lot of talk about subs in the SL series, but of course, I'm sorry, that's a lot of talk about tops, but now we have subs. The SL sub or the SLG sub, G meaning ground. So if you see that, so this would be a box that doesn't have any rigging bits on it. So like front splay links wouldn't be there, or rear splay link won't be there. So that would be obviously just a ground deployed sub on its own. And we can see the same thing for the KSL sub, the KSLG sub as well. SL sub being 321-inch LF drivers, 2 to the front, 1 to the rear. And as you might guess with a KSL, it's the 2 15s to the front and 1 to the rear, so that this box is inherently cardioid. So just as we lay this over to use it, we don't have to flip anything around. This box is ready to go. And in fact, the SL sub itself is probably the best cardioid subwoofer that D&B has to offer. I mean, if we take a look at something that was maybe used quite often in the past, where we had the J sub and the J infra, we could take a look at those polar plots, and we can see that the SL sub is greatly improved. I mean, this, as we say, cardioid, looks very much like a heart shape. And we also had, as the J sub and the J infra, a cardioid and hypercardioid mode, but we don't have that anymore with the SL sub just because it is so well behaved in its pattern control. So taking that same thought process of a J sub and a J infra, once again, something that was quite commonly used together. So the 2 subs, we can kind of take a look at the individual traces there. So the red trace showing what the infra is doing, and then the blue trace showing what the J sub is doing, to give us a combined trace, which would be the green one there, and seeing what the 2 of those do together to help support the J series. So as they're making a new subwoofer, they thought, well, how can we improve on that? And they were able to figure out how to have this red trace. And what this red trace is showing is 1 SL sub compared to the 2 J sub, J infra subs there. And if you're taking a look at this, it's about a dB less than what those 2 subs were going to be. So the efficiencies, the power, the evolution of having more driver technology better available to us as the time has gone on, to really showcase the power and availability of this SL series in the low end as well. So the specs on that, once again, we have the SL sub, the SLG sub, goes down to 30 hertz in the infra mode and still able to have an amazing 144 dB SPL. This is a pair of channels to be able to power this, and it weighs 304 or 138 kilograms. And then the ground version is that 291. The KSL sub then also comes with a KSLi sub. Once again, the I meaning the install variants. So we could see that there's the flyable and ground version for that. This is specifically going to be designed to help us support with installations where flying the subs maybe in an array is something that's appealing to us, right? Where we have that above the physical array, not a separate array. And the KSL sub is just perfect to be able to complement the KSL as it's the same size there. So as you would expect though, there's the NLT4 connection, or if you desire the Phoenix socket as well. With this, it would also require a pair of channels to do that as well. Let's see here. And it also has the variants that we talked about with the KSLi as well in there. So here's kind of that picture that I was talking about. If we were going to do an installation where we had subs on top with the KSLi underneath it there, so especially looking to get that low end into maybe some of the upper balconies or just to fill out the rest of the venue. But the KSLi system, though, as you would hope, is identical to the mobile version acoustically. So even though there may be no handles, it's going to sound the same. And so even though this is a smaller box per se, it really is a no compromise solution to really some of the larger scale or fixed installation venues that we're talking about here. I think by looking at the specs, you might agree that it definitely has some horsepower behind it, be able to help us and support those size of venues. And of course, this is developed for installation specific at heart, by having the clean lines and different rigging options that are available to do that. If we don't need to maybe hang as many boxes, we don't need to use the mobile frame, we can use smaller frames, right? Maybe something that has just a detention mode availability only, because GSL and KSL also have something called compression mode. But we're just going to hang these boxes in the air and hopefully never have to take them down. We don't have to have all those extra bits that are associated with this. So cutting down on cost and cutting down on weight, so we can have some other integration rigging that's associated with that. Or even if the fact that we're going to do a couple of subs, then with KSL tops underneath that, let's go ahead and have a separate frame for that, right? Or even the transition frame in between there to be able to do that transition from the subs to the tops. So once again, things that they're thinking of, this is going to be valuable for installation settings, right? Or if we need to do some extreme pullback angles as well, we have a frame that can go to the bottom of that that's pretty unobtrusive, so that we're able to go and achieve those angles for us. So the custom solution side of things. So there's a whole department that's devoted to helping just that. So they're looking to make the adjustments and special constructions and weatherization, aesthetic features that pretty much precisely take your KSL system and fashion it into your specific project requirements. So by taking any color that you're looking to do with a specific texture, that's perfect, right? Or if we're looking to have it weather resistant, or even if we're in a situation where there's sea weather that we're having to put this in, that we have sea weather resistant variants that have, help for more wet or acidic environments there. And then the special version stadium. And this is going to be something completely different, where it includes threaded inserts rather than the integral rigging that's there. So it's fixed angles, or a fixed skeleton, if you will, to be able to have our speakers already deployed that way, but yet still have the availability to remove a single loudspeaker without having to de-rig the whole thing. So things like that we heard in the market, that would be helpful to where we're going with being able to put these speakers in those kind of situations. And now Chris gets to take over with the last part and bring it home.
All right. So we've been talking about KSL. That's been pretty much the focus. And Dave also brought up the GSL SL series in total. The last thing we want to talk about is powering these cabinets. Many of you may be familiar with the D80, which is our flagship amplifier, and then its little brother, the D20. And then for our installation products, you also have the 10D and the 30D. And we found that there was a bit of a gap, that in order to power KSL, it would have been necessary to install a D80, which for its cost isn't really what we wanted. It's not a great solution. So we came up with the 40D, which is a install amplifier that's been completely redesigned and is intended to power up to the KSL cabinets. And this is a complete redesign in terms of the way we're thinking about this amplifier. You're getting 4 outputs, each to 2000 watts at 4 or 8 ohms. And just like the D80, it's that D class amplifier stage. So you get that really high output for the high impedance loudspeaker design. So we've been releasing recently. GSL, KSL, a lot of our subs of late have been designed to have very strong magnetic motors. And you need the voltage from an amplifier to be able to push through that magnetic resistance. And that's where the 40D is designed to operate. It's designed to be able to hit that very strong voltage push rather than preferring an amperage push. So, what are some of the new features aside from the power considerations? We have more GPIO ports. In this case, we are 8 inputs and 4 outputs, in addition to that general fault input. And it's going to be using the same GPIO settings that we already have on the 10D and 30D. There's just more possibilities for incoming controls. Exceptionally low noise floor and the highest dynamic range we've ever put into an amplifier. In this case, a dynamic range of 118 dB. You have energy saving opportunities for those installations where they need to be certified green or exceptionally energy efficient. The amplifier will now, of course, they all have an auto sleep function. After a period of time with no signal, they'll go to sleep, go into a low power mode. But now with the 40D, we can have an auto wake up on any audio input signal. It's currently limited for our current 4 channel amplifiers, 10D, 30D, D80, D20, limited to the digital inputs. Now you can do it to all inputs. Completely rethought DSP platform. And even better for installation is this improved workflow when dealing with large collections of amplifiers. In this case, the 40D will be able to receive a remote ID from R1. So now we don't even have to go through and manually set the remote ID. We can let R1 tell the amplifier what remote ID it's going to be. So we basically can be hands off. And of course, gigabit Ethernet control for all the 40Ds. We also, unlike our other install amplifiers, we have a touchscreen built into this. And this is a read-only touchscreen. So you can't make any changes from this screen, but allows you to get a very quick view of what the status of the amplifier is by just walking up to it, in case for some reason you hear a problem and you don't have R1 running at the particular time. And as you can see, we've updated the interface a little bit to accommodate that larger touchscreen, but also clean it up a little bit, give it a more modern feel. Then last thing, I just want to let you take a look at some of the specs for the 40D. Again, that 2000 watts per channel. And this is all in a relatively lightweight package of about 29 pounds or about 13 kilograms. Same 2RU space, not too deep, but only 18.3 inches deep. If you're interested in the 40D and with your KSLi installed projects, you should reach out to our sales team or our business development team, and they can walk you through that entire process. And if you have technical questions, you can, of course, reach out to the support team with any of those. So in conclusion, we just want, this whole idea of directivity being important and is a passion for D&B since really our founding, and really gets codified with the KSL system or the SL series in general. And all of the things that go around that loudspeaker system. Because remember, D&B is not just about loudspeakers, amplifiers. It's this complete solution package to, obviously, Dave just talked about the installation specific rigging or the custom solution options that you have with KSL, as well as many of our other products. If you are a user of Revit, we do have Revit models available, so you can pre-plan your system. Of course, everything can be predicted in array calc, array processing for greater pattern control and even tonality. If you're deploying outdoor, noise calc, Dave talked about that earlier, about far field noise prediction, all the way through controlling the system either via R1 or using our R90 touchscreen remote control. All right. I think that brings us to the end. We don't want to keep you guys too long. We know there's plenty of other sessions that you want to attend. So if you have any other questions about anything we talked about today, you can actually send an email to support@dbaudio.com. That is a global email address. If you do happen to be in the Americas, you can email support.us@dbaudio.com, and that will send an email directly to the support team for the Americas. Otherwise, I'd like to really thank you guys for joining us. I really enjoyed having you, and hopefully join us for some additional sessions. Thank you for joining us.
Yeah, thank you, everyone.